me example of a momentary switch that you have in your car. The horn is one, other one. The start. You remember? You remember the start, the ignition switch in your car. The first position is permanent, and you hear that the lights turn on, the radio turn on, no? But the second one is momentary and return to the second one. This one have two positions, one permanent and other momentary. You have another momentary switch in your boat, for example? Excuse me? Boat thruster, and return by itself. Good. Other one, the twin taps, no? You touch, and return by itself. It's momentary in both, in up and down. There are a lot of switches momentary. And there are switches combined. In one position permanent, in the second one momentary. Yeah? Okay. Now we are going to explain the ignition switch. The ignition switch have three terminals. You see? Three terminals. It's a switch. What happened? Here you only have positive cables because it's a switch. I interrupt, or I send for here or for here. The power enter in the position B, battery, and have two outputs. One output is ignition, I, ignition, and other one S, signal. When I select the first position, is ignition, and I activate all the lights in the dashboard. In the second position, I send the signal S to the start motor. Now we are going to connect this ignition switch. How many positions have the ignition switch? Two positions. The first one is ignition, permanent. And the second one is start or signal, momentary. Good? This is other switch that we are going to use. There are other type of switches, like this. This is a switch. Yes. What is the difference between this switch and this switch? Look, in this switch, the current enter here and the current pass over there if I decide open or close. No? This is a manual activation switch. Manually activated switch. Yes? Guys? Yeah? On, off. On, off. I decide. I have the decision. Okay. What about this? I have the current entering here, and this is the output, or vice versa, doesn't matter. This is the input, and this is the output. But in this moment, I have continuity here. Is connected this with this? No. Until you bring a signal, and a small signal, positive and negative, from the ignition switch, from the fly bridge, from the pilot hand. When you bring the signal, a magnet internally close the gap and the current pass to the second one. This is the relay. The relay is a switch remotely activated. It's a switch that I activate from other place. I bring a signal here, the coil create a magnet, the magnet close the gap, and the current pass from this point to this point. Wow! It's this. Look at this. This is this. The current enter here, but here you see that piece of iron, guys. You see that piece of iron, the black one? And I have a coil around the iron, not touching the iron, it's around the iron. What happens when I connect that coil, one to the negative, and the other one, for example, to the ignition switch, 12 volts? What happens when the coil is with power? What happens with the piece of iron?
Pull it down.
Become a magnet. And according with the flow of current, the piece of metal goes down and close the gap between this and the current pass. Bingo! This is the relay. Nice, no? It's a piece of iron, and I have a coil around the iron. When I bring the signal here from the ignition switch, What happened with the iron? What happened when I remove the power here? Here I have a couple of springs. What happened when I remove the current here? The springs open. And now this and this are not connected. What happened when I bring the signal again? And the current pass through the other. For that reason, in the relay, you always hear click, click, click. Remember this element? This one should be connected where? Negative. Negative bus bar. Negative, negative, negative. Negative bus bar here. Okay. I have power here coming from the battery because I activate the switch, no? Now I have current here. I have current in the second side? No, because I don't have signal. Let me activate the signal. The signal is coming from the ignition switch, from the position ignition. In this moment, I have current in the battery, you see? But I don't have current here, and I don't have current here. Danny, can you open the switch? When you open the switch in the first position, you have current here, and you send the current to the relay, and you hear, off, on, you hear, off, on. Oh, nice, no? You hear the click. And now, it's on. I have signal here, and 100% sure the current pass through the other side. Nice, this is the relay. If I remove the signal here, off, I don't have signal here. Everybody follow me? Difficult, the diagnosis of the relay? Okay, I have 12 volts here, no? The voltage of the battery.
You put the sound on cell.
The other side, nothing. But if I turn on the switch,
but you're turning all the way to like
On
start.
position. On position.
on.
The on
And the
position
first-
opens the
the
relay.
Starts
first-
a different.
The first position, only the first one.
So would that not run the starter when you?
No,
No,
not yet.
no.
It just
Powers
powers.
Not
the
yet.
starter.
I bring the power. I bring the power here. I need to activate this one also.
So there's another switch.
Other
on the
switch.
starter. I got you. Okay.
Let me explain
Yeah,
that.
yeah,
Okay. Good? Thank you, Dan. Good, the relay? Is clear the relay? Pay attention to this. I want to send a signal of 100 amps. 100 amps, how big is the cable? It's a big cable, no? I want to pass 100 through here to here. Oh, wow. But I send a small signal. How much is the signal from the ignition switch? Is 100 amps?
No.
That signal is 100 amps, the purple? No, it's 3 amps, it's 2 amps from the ignition switch. Oh, I send a small signal, close the gap, and the big current, 100 amps, pass through the other side. Oh, wow. Excuse me. I have a signal here, 24 volts. I want to pass 24 volts, 100 amps, from here to here. Bam. 100 amps, 24 volts. Can I send a small signal, 12 volts, 3 amps, to close the gap?
Yeah.
I want to pass 24. I want to send, to close the gap, 12 volts or 6 volts.
Yeah.
Yes,
Yes.
yes, yes. With a small signal, low voltage, low amps, I close the gap and I pass the current that I wanted. Pay attention. I have a big boat with diesel engines. And the batteries normally for those engines are configured in 24 volts. No? Big batteries, like the big one that we used the last class, you remember?
Mm-hmm.
2 of them in series, 24 volts. However, in the console, I have 12 volts. Oh, 12 volts for the signal, and I pass 24 for the motor. Look at this. Here I have 24, and 24 enter in the start motor. However, the signal for here is a small signal, 12 volts. I can. Later we are going to talk about that. But you understand the meaning of relay? It's a switch with remote activation. It's exactly like this. It's exactly like this. But this one I activate with my finger. And this one
With current.
with a signal from other place.
How about it uses low voltage to complete a high voltage circuit?
Look, this is
And that's what I'm
this
saying.
is a high voltage circuit.
I'm saying it uses low voltage to complete a high voltage circuit.
No, it's not common. Normally, it's with a small signal you complete a high voltage circuit.
Oh, a low.
Yeah.
A low.
Okay. All right, guys. Everybody follow me?
Yep.
It's clear? This is the relay. And look at the solenoid. The solenoid is exactly the same than the relay. Look, it's exactly the same. The metal is surrounded by the coil. One is a ground, and the other terminal is the signal. The signal from the ignition switch or the toggle switch, any signal. When I bring the signal, what happened with this solenoid? What happened with the gap in between this and this? Closed. But additionally, the metal extends outside. I hear the click, the current pass from this point to this point, and additionally, the metal goes out. Why is necessary an element like this with external movement of the metal? What is the name of that?
Relay.
What is the difference between this and this?
That's a relay, that's a solenoid.
Look, what is the difference? Oh, that one have this metal extended outside. It's the same, but that one have external mechanical movement. This shaft in the relay is enclosed. You hear? But the metal now goes out. Yes or not? In this one, yes. And you can use that mechanical movement for millions of applications. You remember when you go to the doctor, the medical appointment to the doctor, you knock on the door, and the secretary in the desk, and open the door, and you enter. It's a solenoid, and the secretary activate with a momentary button here on the desk. Yes or not? In gasoline and diesel engines, when you turn off the engine, one solenoid close the input of fuel, and the engine stops. No? Give me other example of solenoids. There are millions of examples of solenoids to interrupt the flow of current, the flow of fluids. Solenoid. What is the difference between the solenoid and the relay?
External mechanical.
The external movement on the solenoid. And, this is the cranking system. Difficult the diagnosis of that circuit. We are going to play a little with this circuit, the circuit of cranking. Look at this.
So it's both this.
Yeah, the customer complained that when I select the first position, I don't hear the click of this. What is the name of that relay?
Started relay.
Start relay or crank relay. And what is the name of this?
Solenoid?
Solenoid. Start solenoid. Start solenoid, start relay. Relay and solenoid. Relay and solenoid. Everybody follow me? And what is this?
Ignition.
Ignition switch. The ignition switch. The ignition switch have 3 positions. What happened in the position B?
Start.
B
See,
Battery.
is the power coming from the
Battery.
the battery, and the battery. The power coming from the battery is always with power. What about the position purple? Ignition. That position is the position number
1.
1. When I activate the first position, I have power here. You see? And of course, I have power in the relay. If I have power in the relay, the current here in this moment should be here because it's powered. If I disconnect the power of the first position, turn it off. No power in the output. Now first position, power in the output. Everybody follow me? Okay. Look. The customer says, when I try to start my engine, the engine is doing nothing. Nothing. And you hear a click? No clicks, no nothing. Okay, what is the first step in that scenario?
The battery.
Check the battery. How you check the battery? Load tester. Okay, I have power in the battery. Now, if I have power in the battery and the battery is good, it's supposed that I have power here. What happens if I don't have power here?
The wire.
You have a problem here. Probably it's on the switch selector. Ah, yes, I forget. Yeah, right now, this is the position. Let me check. Oh, yeah, right now I have power here. Okay, you have power in position B. Let me check the second position. I don't have power here. When you turn it on, you have power here, but when you select the first position, you don't have power here in ignition. What is the problem? The ignition switch. Let me jump it with a wire, this with this. Oh, immediately I have power here and I hear the click. Ah, my ignition switch is damaged. For example, let me check if it's good, this one. Ah, okay, with my jumper cable, right now I hear the click, no? Ah, it's damaged, my ignition switch. Let me check the other position, start. Ah, I hear the click on the solenoid. I need the jumper cables always. Can I check directly from the battery? Yes, you check here and here. Yeah, with this. Okay, let me check if the click, I am going to bring positive to this one. Ah, it's this one, the click. Ah, in the second one, nothing. Ah, probably that element is damaged. Let me check if I have power here when I bring power here. In this moment, I don't have power here. When I bring power to ignition, ah, okay, I have power in the big one. Yes, I have power in the big one. And when I have power here, I have power here. Let me check. To pass the power from here to here, I need signal in the yellow red, no? Yeah. Okay, let me bring signal to the yellow red. Ah, the solenoid close the gap, but the current no pass because I need at the same time signal here and signal here to bring the current and push the bendix. Everybody follow me? Oh, I need signal in both of them at the same time. Okay, I need connect this with this and this together. Okay. You discover that the start motor is good. The problem is the bendix, is the solenoid. What is the recommendation?
Change.
Remove the start motor and replace the start motor for a new one. Can I replace only the solenoid? Yes, my friend, but it's a lot of time. In your boat, don't try to fix it.
If you can
replace.
get it apart. If
No?
you can get it apart.
Exactly. Okay, pay attention. Some people say, Mr. Lopez, why in my car I don't have this relay? This cable is connected directly with this and I don't have this cable. In your car, you don't have this relay.
I'd assume because the ignition's really close, so you don't switch it like where
No,
the boat is
no.
powered.
Let me explain something. Imagine a big boat with a couple of diesel engines, big ones. That's okay? All right. And imagine this is one of the big diesel engines and this is the other big diesel engines. And this is the start motor of one engine and this is the start motor of the other one. Everybody follow me?
Yes.
Okay. Normally, in a typical boat, how much is the space in between both engines?
Close.
How much is the space?
Narrow.
It's like this, no? It's narrow. And a start motor here and a start motor here. Suppose that you don't have that relay. In other words, when you turn on the battery switch, you always have power here.
Right.
Suppose that you don't have this. You have power constantly over there. What happens if you are working in other things and you have a couple of tools like this and you touch this with this?
Boom.
Double.
Look at this. Suppose that you have power here. In this moment, you have power here. You have power here. Okay, but the motor is not spinning. To start the motor, you need signal over there. If you are working here with a couple of engines pretty close, and you touch this with this, and a spark, and it's good?
What goes into the die?
Basketball.
No, it's not good. For that reason, in marine application, you install that relay in between this point and the battery to keep this point with no power. Only power in the moment that you start. This is for safety. Yes, in your car you don't have this. In some cars, for use that relay. It's good for safety. Good, my friends?
Yeah.
It's clear? And this is the a.c.r. What is the meaning of a.c.r? Is automatic charging relay, or a battery stabilizer, or battery equalizer. Yeah? For example, suppose that I have in my boat only one engine. Only one engine, of course, with one alternator. And I have in my boat two batteries. One battery for cranking and other battery for the house. It's a small boat. Single engine, one alternator, two battery banks. Okay. When the alternator is running, when the engine is running, the alternator produces DC power. The DC power coming out from the alternator enter here, in the middle. This is the input. And in each output, I connect the positive of battery bank number 1 and positive of battery bank number 2. And with one alternator, I keep both battery banks equally charged. This is the function of this. When this battery charger is fully charged, this element only sends power to this one until both of them are equal. When both of them are fully charged, this element dissipates the excess of energy by heat. You see, with the fins. When both battery banks are fully charged, this element dissipates the extra energy by heat, transfer of heat. Look, this a.c.r is for one input and two outputs, because I only have one source of power, one alternator. Suppose that I have a boat with two engines. Okay, I have this one with two inputs and three outputs, because I have three battery banks and two inputs. What are the inputs? Oh, I have two engines, two alternators. Or I have one engine and one battery charger. One enter here, the other enter here, and I have three outputs. This is two inputs, three outputs. There are other ones similar to this with the three inputs and four outputs. There are different configurations. But the function of the a.c.r is what? What is the function of the a.c.r?
Level of batteries.
Keep the level of the charge in the batteries equal. For that reason, the name is battery stabilizer, battery equalizer, battery isolator, the other name. For me, that name is not according with the reality, because it's not an isolator, it's an equalizer. a.c.r, automatic charging relay. Good? The a.c.r. There are a.c.r with one input and two outputs, two input and three outputs, four, yeah? There are different configurations. This one is two inputs and three outputs. Ah, okay. Those elements are according, this one is maximum capacity 70 amps. Maximum 70 amps. What is the meaning of that? The maximum amount of input amps should be 70 amps. And this element divided those 70 amps in three groups. This one support maximum an input of 70 amps. This one support the maximum 90 amps. One with 90 amps. Good capacity. No? Okay? Depending the capacities of your alternators, the capacity of your battery chargers, you need to select the a.c.r.